In this video, I'll be making some tooling for Windows 3 in preparation of a future game dev project. I haven't really decided what kind of game I want to make yet, but I do know that my current computer is not powerful enough. I'll be getting a new computer next year, but in the meantime I figured I can work on some tooling instead. I'll be developing this in Borland Turbo C++ 4.5, although I will write everything in C. I'm a bit of a grouch that isn't really buying into the current object-oriented everything hype. But step 1, as always, is clearing out enough space on my hard disk. As usual, this included some difficult choices, but I was eventually able to obtain the 30+ megabytes of free space needed. In the installation itself, I'll still want to be frugal with the options I install. Every megabyte saved is valuable the next time I want to install something. And obviously, I can't do a video about using Turbo C++ for Windows without showing this absolutely classic Borland installer. I'm specifically planning for 3 utility programs. One for managing a central list of properties and sprite types, one for defining tilesets and sprites, and a map editor. In the end, I ran out of time and I had to cut the map editor and the sprite feature for the tilesets, but we'll be exploring the WinAPI plenty as it stands. So I got the IDE now, and it's time to start working. To keep things a bit realistic, my only sources of documentation when working on these utilities will be this book, the API documentation included with Turbo C++, and whatever I can scavenge from the Simtel shareware CD-ROM collection if needed. Not that the modern day internet is a very good resource for 16-bit Windows programming anyway, but I'll start with a property editor, as the other 2 programs will depend on it. I've decided to standardize on the large memory model. Memory models is a quirk you need to be aware of with 16-bit x86 programs. On 16-bit x86, you have 2 different pointer lengths, near and far. A near pointer is 16-bit, while a far pointer is 32-bit. The far pointer adds a 16-bit selector to the near pointer. In real mode, this is just a 20-bit pointer with extra steps, while in protected mode it's more like a bank selector in a bank switch system. The small and compact models use near pointers for code, while small and medium uses near pointers for data. Large uses far pointers for both code and data. Far pointers are also known as long pointers. There is also a huge memory model that Turbo C++ for Windows does not support, which allows for data structures larger than 1 segment, or 64 kilobytes. These asymmetrical pointer sizes is one of the reasons that implicit pointer casts aren't always portable in C. First, I need a definition file telling the linker how large my stack and heap is, and how my segments are to be handled. The heap here is the local heap, which is a vestige from real mode Windows, which supported bank switched memory expansions. I'll be using the global heap exclusively, as the local heap can't exceed the size of 1 segment, which is 64 kilobytes. A basic Windows program in Windows 3 will look very familiar to anyone who's used WinAPI before. A difference to 32-bit Windows programs is that WinMain, and everything called by Windows itself, needs to be declared as far Pascal. Far in this case means that the return address will be a far pointer, and Pascal as in Pascal calling conventions. You can't have a function that is both near and far callable, as the function prologue and epilogue will differ. And the far keyword makes it explicit regardless of which memory model you're using. These different pointer lengths are the reason why we have all of these lovely LP prefix types in WinAPI to this day, despite being made effectively obsolete with the 32-bit extension of WinAPI. And yes, the C API hasn't always been the default everywhere. The Pascal calling conventions were faster as they passed more information in registers, but they couldn't handle function with a variable number of arguments. The hprev instance check is for registering our window class if this is the first instance of this program to run. This message loop should also be very familiar. I've always wondered why you need to call translate message first. Apparently, it's some sort of leftover for virtual key translation that happened with Windows 1.0. The window procedure is also pretty much unchanged. It's responsible for receiving the messages for 1 or more windows, and to act on these. Which procedure it is that will handle the messages for a window is decided by the window class of that window, as this defines the type of window and where to send the messages, and which instance is responsible for managing it. And there isn't that much more to it to create a completely empty window. Included with IDE is an icon editor, so I spent some time making an icon for this application before proceeding. With that done, it's time to have a think about the properties I want to edit. I think the primary ones I'm concerned with are the tile attributes and sprite types. Tile attributes are stuff like collisions or if there's any special rules like slippery or automatic movement. Sprite types are for defining types of sprites with regards to what kind of animations they have. Say for example you have a sprite with 4 walking directions, any special action animations or such. I want to capture this in a way that lets me build sprites with an automatically generated code interface that is generic within a specific sprite type. So I get on with doodling up some data structures to capture this data off camera. Which brings me to another thing worth mentioning. The memory protection and overall stability of 16-bit Windows sure had a reputation. An error in a system module, probably caused by my IDE, caused Windows to just crash to a DOS prompt. Lovely. I spent some time adding the tedious boilerplate stuff in preparation of a GUI to hook things up to. I'm not going to talk too much about this since I want this video to focus on WinAPI. Which brings us to the next step, creating some controls. I'm not really a UI designer, like, at all, so I'm going for a traditional parameter dump. A list box with some buttons to summon a dialog, pretty much. For this main window, I'm creating all of these controls in code. And the way you create these controls in code is to create a new child window with the desired control as the window class. They are also just kind of plonked in place at a specified coordinate, so it's up to you to handle resizing and placement in a window procedure. It's hard to see when there is no entries in it, but there is a list box here. With some buttons, and it's looking like what I had planned. So I guess it's time to create some dialogues. I won't be creating these in code. Instead, I'll try the dialogue editor that came with Turbo C++. This allows me to relatively easily place out the various controls I need in a window. So I'm able to rather quickly make up some dialogues for both the tile attributes and the sprite type. These are saved in the same resource file as the icon, and is linked into the executable. The Windows API centers quite heavily around resources bundled into the executable. Aside from dialogues and icons, you can also bundle bitmaps and tie menu bar trees, string tables, and so on. These are assigned an identifier via a header, that is then shared between the resource file and your application. As my main window don't have these integer identifiers, I decided to double check that I understood how the messages work, by connecting one of the buttons to a message box. And it seems I understood it right, so I'll carry on with implementing the dialogues. I did a bunch of off-camera work to add remove data from the data structures, as well as saving and loading it from disk. These function calls is what I'll want my user interface to hook into. Anyway, the dialogues need a window procedure just like other windows. A fun quirk with these is the need to wrap your dialog procedure with a make proc instance call, which creates a func for restoring the data segment before calling into your code. This again is a remnant from the Windows 1.0 days. In Win32 it does nothing. With the dialog box call, you then enter the dialog box procedure, and this will block until the dialog box finishes. You had to be a bit careful with this, especially if you're using message passing. Sending a message will grow the stack as you call into the next message procedure. Any kind of feedback loop where one message results in another being sent could easily go out of control and crash the system. Deadlocking this system was also frustratingly easy if you dared trying to be clever. Especially since this is all cooperatively multitask. If you deadlock one process, you deadlock your entire computer. The dialog process itself is just like a window process. This is where we need to implement all the logic for the dialog box, including the conditions for closing it. With a small skeleton of a dialog process, I can summon the dialog boxes I created earlier. But I'll need to wire the controls up to some actual code before they'll do anything. The first step to that is just grabbing the contents of the input field. I can then input them into some hooks I prepared in order to check that they are acceptably formatted. This will later require different handling depending on if we're adding or modifying a property. If the formatting isn't acceptable, I'll just throw an angry error message at the user and leave the dialog open. And aside from a spelling error in the error message, lovely, it appears to work. With the spelling error fixed, I can move on to other things. Details like setting the maximum string length for the input field in the dialog box. Like most properties of Windows controls, these are changed by sending messages to the control. This then continues with some extra logic to handle the two different cases of adding a property versus modifying it. Now that I have a way of adding properties, I can look at populating the list box in the main window. This is also done with messages. I don't go for any cleverness here, I just empty the contents and add it all again. And that works just like expected. In order to respond to selections, I could either query the current selection, or I could grab the message it sends when it changes. As I want to enable and disable the edit and delete buttons when the selection changes, I go for the message route. I still need to query it for the actual selection though. Since my tile properties aren't necessarily contiguous in my data structures, I can't assume that the index used in the list box matches with the one in my data structures. So I have to query for the string and then look that string up separately. But with that, the buttons now respond and I have to make edit actually edit an existing property. This is mostly about loading the controls with previously saved data. You end up spending a lot of time in the SDK documentation just looking up these messages and parameters. I have to say, having the complete Windows 3.1 SDK documentation available in a Windows help file is quite nice. But with this, I should get the existing properties filled into the dialog box when I click edit, and I do. Since I already have the logic to delete properties, I just add a lazy "Are you sure" dialog before passing it on to the delete call. With the tile properties done, I can move on to the sprite properties. These are going to be very similar to the tile properties. The difference is that I'll have a second level of properties. The idea here is that I define types of sprites and then list each animation type that this sprite needs to have. But as a starting point, I just copy all the sprite property code and start tweaking that. The first level of properties is almost identical, so I only need to change some function and variable names. The second level is mostly just copy-paste from the main window, what with handling the list box and such. With all that sorted, I guess there's only a load save feature left to implement. This brings us back to the resource editor, which has a mode for building menu bars. Just like in the dialog boxes, you don't connect any code to the menu controls at this point. You assign them identifiers, which allows you to recognize them in the message handler. The menu is attached when the window is created, so I just need to load it and provide its handle here in the create window call. For the actual save and load functions, I have existing hooks in the code I wrote off camera to deal with the data structures and such. As I put the code in to trigger the load and save, I add this flag that I'll use to keep track of unsaved changes. The last major GUI element I need to work on is the open save dialogues. Windows has a common dialog library with ready-made dialogues for this. We do require some setup though. First, I need a list of strings that will describe the selectable filters and file types that it will show, and then we need to summon it. This is an example of the huge number of arguments some WinAPI functions take, and has earned it some criticism over the years. To get an open or save dialog, we need to fill in this struct with a fairly large number of arguments, many of which seem redundant or unnecessary. After placing some dummy code in my save menu handler, I can see that I am indeed able to get the path and file name of the saved file, which, when patched into my hooks for actually serializing and deserializing my data structures, actually seem to work. As the final bit of graphics interface work, I make an about box in interface editor, and I quickly copy-paste some dialog handling code for it. And as a final touch, I go through the code and find every place where the data structures are modified from the UI, and sets the changes made flag. That flag is then used to warn about unsaved changes when you create or open a file, or exit the program. Which brings me to the last message I need to handle. The WM close message is where I'll handle the unsaved changes dialog, as we still have a way to prevent the window from closing here. But I think I'm pretty happy with my property editor now. I'll just build a version without debug symbols, and I'll move over to the next program to write. After quickly drawing up a new icon for it, it was time to start copy-pasting code from the previous one, for stuff like registering a window class and creating a new window. I once again spent some time off camera to work on the data structures and code to load and save from file. As the tile sets you create depend on information like what property file to use and what size the tiles are, I need a dialog to fill that in when creating a new tile set. I also need a dialog box for adding graphics. The graphics I'll pick the actual tiles from, and from there also a dialog for actually editing the graphics entry. Now we get to one of the more exciting things in this project. I want to make my own control for embedding into Windows for selecting a tile out of many. Creating a custom control is a lot like creating a regular window. You set up your window class for it, just like we've done before. But instead of creating a full window, you instantiate it as a child to your window. I've never done this before, so I'm kind of fumbling my way through this. To start things simple, I create a window class handler that simply paints the window grey. I just want to know that I'm able to control what's drawn. I then instantiate this control into my main window, and I get a grey box of the expected size in my window. So far so good. As I want my main window to pretty much just be this tile selector control, I use the window resize message to resize my control to the new window size. If you want to make a resizable window in WinAPI that resizes and moves controls, you have to do it yourself in code using this size message. And that too seems to work. Now, to draw tiles in this control, I need the control to have a pointer to the data structure containing that information. As we want this information to be tied to the instance of a control, we somehow need to tie it to a window. To do this, you define in your window class that the window is to be allocated some extra memory. You can then access this extra memory with getWindowWord and getWindowLong. WinAPI has a long tradition of smuggling pointers as longs, and I suspect this caused no end of trouble later during the 64-bit transition. This is also how you send pointers in messages to Windows. You stuff them into the lparam field, or long parameter field. After an obscene amount of copy-pasting, I got enough dialogues that I can start thinking about loading and drawing graphics. For no particular reason, I decided to just smear something out in MS Paint for me to use as a test picture from this point on. The choice of color was a little unfortunate. If you don't know how it's supposed to look, you'd think it was inverted or something. I currently don't have more code than that I can pick the test file in a file browser, but it's a start. As you might be able to tell, I support two image formats, at least for now, Windows bitmaps and GIF. And to everyone having opinions about how I said that last one, be assured that I do say it with a hard G in other languages. For the Windows bitmaps, writing a loader was trivial. The SDK documentation includes full documentation for the format. For GIF, it was a bit more annoying. I did find the GIF89 spec on my shareware CD, and it's pretty complete. In all regards except for the hard part, which is the actual LZW compression. I did find hints and clues about how LZW works on that CD, but without already understanding LZW, it wasn't of much help. Thankfully, I was able to piece it together with the description I found in the compression folder on the same CD. I wrote all of these image loading routines off camera, because I am already drowning in footage of me staring at non-functional code. Anyway, I've now wired it up enough that it'll attempt to load the image, and we get our first glimpse at the debugging features of Turbo C++. This kind of error sounds like a division by zero, but we don't need to guess, we can inspect the contents of my TL structs. Sure enough, both tile width and tile height is 0, like everything else in the struct. As I haven't created a new tileset in this test, it never initialized these parameters. With the new tileset dialog box implemented, where I can actually specify the size of the tiles, I can now load graphics without a division by 0. With some more GUI code in place, and most of which I copy-pasted, it's time to shift my attention towards the tile select control I started on earlier. Before getting into drawing the actual tiles, I figured I'd start with the parts that didn't scare me. To start, I want to draw some grey boxes representing the tiles. This included quite some head scratching and struggles with basic geometry. It's just a bunch of maths and basic fill commands at this point. The scroll bars aren't tied to a big canvas like you'd see in modern GUI toolkits. Rather, you have to redraw the view to match the scroll bar position yourself. And you also have to manage the scroll bar attributes like how many steps of scrolls there are. On Windows 3 and earlier, unlike Windows 95, proportional scroll bars aren't a thing yet. There is just this little nub that shows roughly where in the view you are. With the squares in place to represent tile graphics, I want to implement selection. This means translating a mouse cursor position into a tile number and then showing this in the control somehow. The latter is pretty easy. Since I already keep track of the ID of the tile I'm currently drawing, I can compare that to the current selection and just draw a slightly larger black box first. In the message handler for the control, I can pick up the message for scrollbar events to handle scrolling, which in my case means adding an offset to which tile I first start drawing. The most complicated part of this is using the size of the control and the size of the tiles to calculate how many rows and columns there are, and how many are visible at one time. But with the scroll handling seemingly done, aside from this weird double refresh issue, I guess I can look into using the mouse clicks to select stuff. There's a special message for the left mouse button being clicked, and we can easily get the control relative coordinates from lparam. From there, it's just a matter of working backwards from the number of rows and columns of tiles, and how far down we've scrolled down to figure out exactly which tile was clicked. Which I somehow managed to do, because now it's working. As a final thing there, I have it send a message to the parent window whenever the selection changes, just like regular Windows controls do. Now I want to add activation. Basically, I want to be able to double-click a tile to start editing it. I didn't seem to be getting the double-click event though, and this had me confused for a moment. But it turns out you need to have a special style flag set in your window class to get it, so I guess I have to add that. Which fixed it, I can now detect double clicks. which means I need to make a new dialogue, to shove into the face of the person that just double clicked on a tile. The idea here is that you can set one or more frames, selected from the various graphics resources you have loaded. Multiple frames are for animated tiles, to make the maps a bit more dynamic. This is also where the tile attributes are linked. I probably could have made this in a cleaner way than placing 16 checkbox controls, but oh well. I do reassign the identifiers for them though, to make it easier to manipulate them from loops in the code. This is also where I get another encounter with the debugger, this time a proper seg fault in my tile selection control. This was just me setting a window word with a wrong index, corrupting a pointer. It's kinda sketchy how Windows make you do your own static memory allocation, as error prone as it is. I got that fixed, which brings us to the next interesting bug. My window is drawing without a background, or title bar. It's just child controls. This one also had me confused for a bit. I thought it was a weird window style or something that was set, but it turned out to be far simpler than that. My dialog process would return true if it had an unhandled message. It should have returned false, and with that change my window now looks correct. You also might have noticed that I'm reusing the tile select control in this dialog. I intend to use it to select the tile from the graphics resource as well. As I continue to wire up the dialog, some of the code is a lot less pretty than other parts. The property handling especially I'm not happy with, but it'll do for now. I really wasn't looking forward to dealing with the actual graphics, so I spent a few days just working on the UI, fixing bugs and making the dialogues behave like you'd expect. I even got the unsaved changes prompt added during my procrastination. Adding polish is a lot easier if you got a bigger and more important task waiting for you that you just don't want to tackle. But I can't put it off anymore. This is literally the last remaining feature. To get graphics on screen, there's really two things we need to do. We somehow need to load our arbitrary bitmaps into WinAPI, but we also need to set the palette up to match the graphics. The WinAPI documentation isn't really holding your hands in regards to any of these, so I'm a little unsure how to even tackle it. I'll first start with trying to load a palette. As part of my image loader, I do record the various colors used, and I do make a table of them. So I guess I'll just start with writing some code to load that as a palette and see what happens. I've already taken into consideration that Windows reserves the first 20 colors for its own use. What I'm less sure of is if Windows will allocate mine exactly as I request them and in order, or if I'm gonna need to translate my pixel data. This palette handling will be done on the application level and not in the tile edit control. This is because there may in the future be other controls in use that also have requirements on the active palette. You start by allocating a data structure large enough to hold all the colors. You then initialize it with the number of colors present as well as the version of the struct. I then need to put the color data into the struct. I don't know if I need to do this, but I also load the lower 20 entries from the system palette into mine. There's also a select and realize step. Realize is what actually puts the palette into use. I then just try to add my recalc palette hook in all places I think might need it. This is also when I'm going to need to be really careful about releasing handles and such. Pretty much anything working with these device contexts uses GDI handles, a resource more precious than RAM on Windows. There is a finite amount available system-wide on Windows, and if you leak too many of them, you need to reboot. Regardless, something is wrong, as it seemingly fails to realize the palette. At some point I started second guessing where I need to realize the palette, but in the end the main window wasn't a bad place to apply it. Actually putting the pixels on screen wasn't so bad though. I had already loaded each tile into separate buffers no larger than the tile itself, so I could just create a bitmap object and directly give it the pixel buffer. The drawRect call was just replaced with a bitblit. And then I made sure to release all the GDI handles I had just created. Not super efficient all this, but it should work, and it sort of does. The colors are all wrong, but the shapes are recognizable. I just need to fix that palette thing now, right? This had me properly stumped for a while, and I was starting to question if I could even do it this way with create bitmap and bitblit. Eventually I found the problems, because there were two of them. First, I need to unrealize and delete the old palette before creating and setting a new one. It seems you're only able to realize a palette once, or something. The other was that I didn't run color pack on graphics when loading a tileset, which meant the palette data wasn't set up correctly. But with that, the color is now showing correctly. Now there's just one thing left I want to do. The property editor and the tileset editor both share a bunch of code, and future programs will too. Wouldn't it be nice if I didn't have to include all of that code in every single binary? Windows has a solution for sharing code between executables called DLLs or dynamic link libraries. I'm going to put all the property handling and image loading into a DLL. DLLs on 16-bit Windows are slightly quirky, but it's not too bad. I start out by just adding all the files I have in the rescom directory, which I created in preparation of doing exactly this. I then look at one of Turbo C++'s example projects to set up my module definition file. According to the documentation, you need an entry point called libmain to set up your data segments and such. I tried without one, as I don't use the data segment, and I think I got away with it. Data segments are arguably one of the quirkier things with DLLs on 16-bit Windows. You only get one copy of your data. If you use that DLL in multiple instances of a program, or in multiple programs, they all use the same copy of the data segment. If you have a need for per instance data, this quickly gets messy if you don't let the main application hold on to your pointers. This all seems to build, but I do have some warnings about trying to export non-public symbols. This is a confusing warning because the actual problem is that the symbol I'm trying to export doesn't exist. The compiler adds an underscore to all symbol names, and I need to include that when I'm specifying stuff to the linker. If I add the underscore, the warnings are gone. Now we just have the slightly annoying task left of listing all the functions I want to use from outside the DLL inside my definition file. All I really have to do to use it later was to adjust my include statements to use the new paths, as well as add the import library to my project. This is a small static library that will help the linker bind to the DLL. I then gave the Tileset program the same treatment, and I think we're done now. So, what are some overall impressions of Turbo C++ 4.5 for Windows? Well, scrolling is slow, but that's mostly a problem with my computer and its underwhelming graphics performance. Especially lines that are too long to fit on screen are a bit of a pain to deal with. I didn't really use the debugger much, in fact I actively avoided it. 16-bit Windows is a cooperatively multitask system. If anything unexpected happens to a running application, the whole system is compromised. Intentionally breaking the expected execution flow always seemed a bit sketchy to me. I did have a few crashes that summoned the debugger, and the moment I let my guard down... Yeah, that's what I mean. It's not only Turbo C++ that crashed with my application, it took Windows down with it. The iteration cycle works alright, but Turbo C++ really makes it hard to ignore that I just don't have enough RAM. Even linking takes a while, and then the program being debugged slowly starts its way up. Precompiled headers makes it go a little faster if you're willing to give up several megabytes of disk space for it. It certainly doesn't feel all that turbo. I am really looking forward to getting a new computer next year. I've put all the code on my website if you're curious, link in the description. But I think that will do for this video. Check back next week when I'll be building a homebrew 68K computer from scratch. Until then, thank you for watching.